शमशीर कैसे हो?
वालेकुम सलाम अल्हम्दुलिल्लाह सर, आप कैसे हैं?
Good. Alhamdulillah. Alhamdulillah. Okay. Okay. I have given you some space for those questions which need a lot of working. आप लोगों को याद होगा, I have solved this question during yeah, during the lecture, if you remember. Is it?
Yes, sir, बिल्कुल.
Okay. So that is why its right option was option A. If someone has doubt in this question, you people can ask me. Yes. Is there anyone who wants to uh, get its detailed discussion again?
नहीं सर, सही है.
Okay. So moving on the next one. This question is basically which displacement time graph best represents the motion of the falling sphere. Falling sphere, the initial acceleration of which eventually reduces until it begins to travel at constant terminal velocity. So, you know, all the graphs are displacement time graphs. So in displacement time graphs, the gradient is equal to velocity, and if the gradient is increasing, then we have to talk about the acceleration. So simply speaking, for terminal velocity, if you see that what would be the behavior of velocity, it would be something like this. Is it? Anna?
Yes.
Velocity is this. So what would be the acceleration then? Acceleration will be something like this. It would not touch the zero, but in some cases we can say, sorry, it will touch the zero. Sorry, it will touch the zero. Why? Because acceleration will go to zero. Acceleration will go to zero. This is your, if I have the acceleration time graph, it would be something like this. So displacement time graph है. So displacement time graph में, do you know that initially acceleration would be more, so gradient would be increasing, and then gradient would be become constant. Yani the velocity here, the velocity will be constant. So velocity mean gradient of the graph. So if the gradient is constant, I can simply say that the graph which has constant gradient at the end, that is your acceleration time graph. Is it? Okay, so according to that, what about option A? In option A, the gradient is maximum, then uh, it is decreasing. So this graph is deceleration graph, right? This is what deceleration graph. This one, its gradient again decreases, so this is deceleration graph. If it would be velocity time graph, then this would be the right option, but it is not. Then option B, the gradient is zero. It means the velocity is zero. Then the object has just dropped. So when the object has just dropped, so definitely object has initial velocity zero. Then its gradient increases. When gradient increases, it means that the acceleration, yani the velocity increases, and when velocity increases, it means the acceleration is constant throughout, because there is a decrease in this all gradient equally, sorry, increase in the gradient uniformly. So this is without air, without air resistance, right? Then what about D? In D, initially there is a constant gradient. It means the acceleration, sorry, the velocity is some velocity has some constant value. Velocity has some constant value. Okay, is it clear to all?
Yes, sir.
Okay, just it is not being erased. Yeah, just a second. Okay, yes. The next, its gradient is increasing. It means acceleration is there. Yani gradient increases mean, when gradient increases, it means velocity increases and there is an acceleration. And during this all, if you see, the gradient is constant. When gradient is constant, what does it mean? That velocity, yani velocity is constant, or you can say speed is constant, so acceleration goes to zero. So that is why option D would be the right option. Is this very clear to all?
Yes, sir, sure.
Yes,
Okay.
sir.
The next, yani actually, most of the students have the confusion in graph B and graph D. Graph B is something like that, something same like that, but its gradient is not getting constant. Its gradient is um, basically increasing continuously. Then next is, yeah, this was another horrible question. Overall, that paper was bit, you know, hard paper. If you people got good scores, then it means that you have prepared a lot. This is the displaced distance upward, distance downward. Um, a mass of on one end of a spring bounces up and down. So initially, it is. I mean to say that I have to draw a graph for you. This is its equilibrium. Yani this is its equilibrium position. Let's say, yeah, let's say this is the equilibrium position of the spring. This is the equilibrium position. This is the lowest position, this one. And then after that, the ball will go back to the equilibrium. Then it would be compressed, and then it would go back to the equilibrium. Then it would be extended a lot, mean back to this point, and so on. Right? Is this clear to you? So it means this is your position number zero. This is your position number one. This is your position number two. So zero, one, two, two. This is your position number three. This is your position number three. This is your position number four, and this is your position number four. Is this all clear to everyone?
Yes, sir.
Okay. Now, the question is, which graph shows how the velocity varies with time? Velocity varies with time. So the main problem is there are two important identification marks with you people. That is, when the object is at the extreme point, yani spring is at the extreme point, then it would reverse its direction of motion, so its velocity should be zero. So it means at position number two and position number zero, the velocity should be zero. And so same for position number four. Am I right? Velocity, not the speed. Velocity. So if it is velocity, it has to reverse the direction as well. Is this point clear to everyone?
Yes, sir.
Okay. Now, if I say that here upward velocity, yani velocity upward, and then sorry, the velocity, this is upward velocity, and this is yani here it is downward velocity, and so on. So at position number zero, it is zero. At position number one, it is maximum. Yeah, I did not tell you about maximum, but I told you about zeros marks. You have to mark the zeros positions. That okay, at position number two, it must be zero. It is at zero. Position number four, it is zero. So it seems to be a correct description. Okay, let me explain you further graphs. Then I will go to the right option. Here, the velocity is set to be zero at position number two, which is incorrect, and zero at position number sorry, just a second. What did I do? Oh yeah, this is something wrong. This is maximum at position number two. This is position number two, which is incorrect. It is zero, and it is shown that it is maximum at position number four. It is incorrect. Then again go to this point. Although it is zero, although it is zero, but it is said that the velocity is increasing, then decreasing back to this point, and then increasing and then decreasing back. So velocity has the complete cycle as the cycle of your spring, right? So that is why at position number two, although velocity is zero, at position number four, although velocity is zero, but the problem is velocity would have, for example, when the spring is going upward, sorry, from this point, 0 to 1, it is upward, and 1 to 2, it is also upward. So direction cannot be reversed. Neither the velocity would be, you know, velocity has a change in this way that from extreme position this the velocity increases. Yani, if I say that from position number 0 to position number 1, velocity increases, and then velocity goes back to 0. So that means it cannot be 0 before 2. So that is why C is gone, and D is, you know, D is simply a sort of uh, question in which the gradient is shown to you. Okay, here the velocity is Okay, velocity is zero, but velocity has to reverse the direction. So because in this graph node where reversal is evidence, that is why this is incorrect. So that is why your option A is correct for this question. Is it clear to all?
Yes, sir.
Okay. Go back to question number four. Question number four is a student cycles uphill from uh, home to a shop taking 10 minutes. The student then spends 5 minutes in the in the shop before cycling home downhill at twice of the initial speeds. Okay, uphill, the cyclist uphill from the home to shop, it takes 10 minutes. Okay, and then he spends 5 more minutes there at the shop. It means that is at rest, and then down the hill with uh, twice of the speed. So when it moves down the hill with twice of the speed, it means um, the velocity would be double, definitely. Is it? Okay, no. Um, which graph could be the variation of the time and distance traveled by the cyclist? Distance traveled. Remember one thing. So distance is also always increasing, right? Distance is always increasing. So do you know? Uh, first, it takes 10 minutes to move uphill. Got it? It means here, okay, one more thing. For distance time graph, you must now, it is constant speed. Okay, this is at rest. This is again constant speed, but as it is distance, so it would be moving upward. Yani, it distance will increase definitely as it is moving upward. But the problem is when it is taking its speed double, when its speed is double, so gradient will be double than that one. Is this all clear to everyone? So according to that, all circumstances, this would not be there. It is gone. This would not be there. It is gone because distance cannot be go. Distance can never be zero. That is the logic for these two. The distance can never be zero. Okay. Then in this one, if you see, the first part is okay, it is taking yeah, it takes 5 minutes uh, to yeah, it has constant speed for 5 minutes, which is not mentioned here. The student cycles up the slope shop taking 10 minutes. So it means for 10 minutes the student has a constant speed, then the student is at rest, and then the student is moving down the hill with double speed. So gradient of this, yani, did you see, it is till 10 minutes, then gradient of the second line is double than that of first. That is why option D would be the right option. Any question till this point?
No, no question.
Okay. Now, this is a question of velocity and time graph. So, which graph shows the variation with time t of the distance d fallen by the skydiver? So, who will explain it to me? It is distance time graph. So, distance time graph means again, what you have to do, you will have a sort of um, gradient concept. So, if its velocity is zero here, sorry, if its velocity is constant here, it means the gradient should be constant. So whose gradient is constant? Only in A and C. So B can be crossed, D can be crossed. Just a second. Sorry, D. Just a second. Let's check the D again in depth. Hmm? Okay, initially, when it is dropped, its acceleration would be the acceleration of free fall. When its acceleration is free fall, definitely its acceleration would be the highest. So it means the gradient should be largest. So here the gradient is zero. Initially gradient is zero. This. So here gradient goes to zero. So that is eliminated. Is it clear? Are you getting my point? So you are left with only 2 points, A and D. In this one, the gradient decreases. So when gradient decreases, it is the deceleration graph. Is this point clear to everyone? That is why it is gone. So because the parachutist accelerates, then its gradient should be increasing in pattern. This is the gradient. So the option A is the right option. Should I move on? Okay.
Okay.
The next one is basically the setup of your velocity time graph, and you have to convert that which graph shows the best with displacement time graph. So uh, displacement is also a vector. So here it's gradient, sorry, velocity decreases. So velocity decreases mean gradient should be decreasing. Am I right? And again, velocity increases. It means gradient should be increasing, but the rate of gradient should be constant. Yani, it should be a sort of graph in which initially the gradient should decrease and then gradient should increase at constant rates. Okay, so which graph is like that? Yes. Can anybody tell me? Okay.
It's like
So if okay, okay, bolo.
graph A.
Yes, sure. Very good. Graph A, because its gradient is increasing, sorry, decreasing, and then gradient is increasing. And do you see? It is just a symmetric sinusoidal curve. That is why I can say that it is the same increase and decrease ratio. But in these two graphs, its velocity one is greater than velocity during second half. Okay, uh, and both the velocities are actually constant, which is incorrect. Here it is deceleration, uniform deceleration, which is not taking place there. It is deceleration and acceleration graph. It is it is basically constant velocity upward and constant velocity downward, because gradient is not changing. Na problem ye hai Sara, constant velocity downward. So is this all clear to everyone?
Yes, sir. Clear.
Okay, good. So right option would be option A. Then this question is for the bouncing of the ball. So I have explained this graph as well. If you people remember that all explanation, that the ball is released from the rest above the hard horizontal surface. Rest, it means its velocity should be zero, right? And at this point it hits, and at this point it bounces back. Again, highest point. Again, it hits. Again, it bounces back. Got it? ये पढ़ो बच्चे बैठ के. Okay, is it clear to all? So, at which point on the graph does the ball reaches to the maximum height after first bounce? Okay, now this is your bounce number one. So where is the height? C. Is this point clear to everyone?
Yes, sir.
Surely clear.
Yes, sir. Clear.
Okay, so these type of questions are, the questions which explains entire concept of your graphs. The next one is, what is the next one? This is basically again the velocity time graph, and in that velocity time graph, what do you have? You have a setup of what? There is a grid given, and on the grid given, you have a sort of points out on in seconds, this, and so on. The uh, the vehicle moves at 4 meter per second, begins to accelerate at time t is equals to 0. What is the vehicle's acceleration at time t is equals to 3 seconds? At time t is equals to 3 seconds. So most common mistake in this is the student divides 6 divided by 3. And there is one option here. So examiner, the student says, oh yeah, this is the right option, but actually it is not. You have to take the gradient. So when you have to take the gradient would be taken in this way. Just a second. Okay, sorry, it is just stuck. Take the gradient, and when you are going to take the gradient, one value is over here, the second is at this point. So it is 13 and it is 2. So 13 minus 2 divided by 7 minus 0. So it will be 11 by 7. So what would be your right answer? Sorry, don't know. 11 by 7.
So
1.3?
1.57. 1.57 तक आया.
1.57. Okay, so actually this is hang. So I could not find the proper gradient. Maybe it would be here at this point. So if it is over here, 12 minus 2 divided by 7. So it would be 7 divided 10 divided by 7. So 10 divided by 7 should be 1.3.
It is 1.4. So मैं आपको मैंने भी इसी तरह
1.3.
ना उस पे बनाया था. ऑनलाइन ही बनाया था. मैं बेशक व्हाट्सएप कर देता हूँ जो मेरा ग्रेडियंट बना हुआ है वो 1.33 आ रहा था उस पे जिन मार्क्स पे
1.33
था.
आ रहा नहीं. Yes, that would be fine basically.
क्योंकि मैंने वो
ठीक है?
लाइक स्केल उसका यूज किया था जो.
ओके, जस्ट हाँ मुझे भेजें जरा. Okay. Yes, perfect. That is good. This is very good gradient. I want to share that gradient with everyone. Okay, ये ऑनलाइन कौन से सॉफ्टवेयर पे किया आपने?
से तो जो स्क्रीनशॉट है उसकी क्या कहते हैं विंडोज की.
ओके, स्निप
स्निप एंड
स्निप
स्केच.
वाला.
जी सर.
ओह यस, ओह काफी अच्छा है. Okay, this software, my software is not responding basically. That is why I am unable to even post it on this one. So just let me share screen with you people. Here is the graph, what is accurately drawn. Okay, this is the graph. Do you people see it? Yeah, this one. Is it visible to all? So this is the exact yani tangent, and then after taking it, you have to take the gradient of the tangent. Okay, is it clear to all? Clear to everyone?
Yes, sir, clear.
Okay, going back to the point. Okay, yes, now it is working. So this graph is yes. It is said that the identical cars P and Q are traveling along the straight road. The car Q is traveling at twice the speed at that of the car P. The brakes are applied to both of the cars, producing the same constant deceleration. Same constant deceleration. So which graph should show the velocity v variation with time t? Okay, so what should be the right option for this one? Because car q travels at the twice speed. So twice speed mean q graph should be starting uh, I mean a bit above the q, yani double as compared to that of p. Okay, so here the most bigger misconception is option C. The student thinks option C is the right option. How many of you did that? No
Sir,
one?
I did that.
मैंने तो ये
Okay.
किया था.
Yes, that is the problem. Yani, here the gradient is same. Both have same gradient,
Yes, sir.
right? Okay. So when it is said that the deceleration is same, it means that car which has uh, double speed, yani twice the speed, it should be stopped at double the time. Okay, wait. Maybe I have misconception. Sorry. That one was this one. Yani option A was the main misconception because when it has double the speed, then the gradients are having its gradient is twice than that of q. So this option A means the deceleration of q is double than deceleration of p. So is this mentioned anywhere? No. It is mentioned that they're producing the same constant deceleration. So when they're producing the same constant deceleration, it means their gradients should be same, right? Because deceleration velocity time का gradient क्या होता है? That is your deceleration, na? So that is the right option. Sorry, I just got the mistaken because I just shuffled the options in one of the paper. That's why. Okay, is this clear to all?
Mm.
Okay. The next one is this one. Four cars A, B, C, and D moves from rest in a straight line. The car takes the same time to accelerate to the velocity of 60 kilometer per hour. 60 kilometer per hour. Their velocity time graphs are shown. Which car reaches the velocity of 60 kilometer per hour in the shortest distance? Shortest distance. It means uh, when the car is taking shortest distance, its velocity time graph should be, uh, yani its acceleration should be larger, isn't it? Initially, its acceleration should be larger, or you can say that, for example, this is the velocity and time graph, and we have to keep this distance under consideration. So it means that uh, 2as equals v square minus u square is one of the equation, and second equation is s equals to ut plus 1 by 2 at square. So when it is 0, it means it is 1 by 2 at square is the graph. So that if the car has to, you know, if the car has to travel the shortest distance in the same time, the acceleration of the car should be the largest. Yani it has to, yes, it has to create the largest acceleration. Is it? Wait. 60 kilometer per hour speed. Yes. So we have to find the speed, and time is the same factor. So preferably we can use this equation that 2as equals v square. So the final speed is same 60 kilometer, same time. So S and S is equals to V square divided by 2A, or A is equals to V square divided by 2S. So that car which has to cover the shortest distance, its acceleration should be the largest. So which car has the largest acceleration? You have a choice. The choice is if car A, if you see the acceleration of car A, the uh, maximum speed, yani the car has maximum acceleration initially, and then it reaches yani its velocity is going to be constant. And here, this car A and D can be the comparison. Then this car has the lower acceleration initially, and then it moves with a larger acceleration later on. But the symmetry of the graph is same. So in that case, what you have to consider, yani the idea is, what is the idea? Idea is very interesting. Area under the graph, right? Area under your graph is distance. Am I right? There is no other way to solve this question. No other way. So if you have this concept that if the distance is shortest, then the area under the graph should be shortest. So in A, if you see, the area under graph is largest, and in D, area under the graph is smallest. So that is why what would be the right choice? D. Is it clear to all?
Yes, sir, it's clear.
Yes, sir. Clear.
Okay. Now the questions are basically from projectile. The stone is thrown upwards and follows a curved path. The air is negligible. Why does the path have this shape? Wow. Why does the path have this shape? Because if we consider the vertical and horizontal velocities, the velocities, horizontal velocity is constant throughout, and vertically it has acceleration, right? And stone has a constant horizontal velocity and constant vertical acceleration. Okay, we can consider this. Stone has constant horizontal acceleration. No, it is severely wrong. It does not have any acceleration. Stone has a constant upward acceleration followed by a constant downward acceleration. Um, Upward is the deceleration of the stone actually, right? It has a deceleration while moving upward, and then while moving downward is the acceleration. So stone has a constant upward velocity followed by a constant downward velocity. No, this is an incorrect option. So okay, these two options can be considered. The stone has a constant horizontal velocity and constant vertical acceleration. That is the reason, because while it is moving upward, its acceleration is 9.81, and while it is moving downward, its acceleration is again 9.81. So with respect to term, the acceleration is constant. That is why option A can be the right option. Okay.
Yes, sir. ठीक है.
Yes, sir.
Okay,
Okay.
then how many questions are left? Oh, there are so many. Yeah, okay, four more questions are left. Just a second, just make it quick. Okay, there is a velocity time graph here. The train. Okay, good. This is a good question. The velocity time graph of a train starting from one station and stopping at the next station is given to you. Another train has double the acceleration, but the same maximum speed and the same deceleration. Right. So double the acceleration means this first half should be having double gradient. If the gradient would be double, the time would be shortened, right? And top speed should be same as well. So top speed should be same. Yes, and this graph should be falling one, two, three, four, six, seven, 8 lines, and 2 lines, 8 and 2 lines, and then this should be 8 and 1, 2, 3, 4, 5, 1, 2, 3, 4, 8 and 2, right? 8 and 2. You have to find out this is 8 and 2. Then top speed same, and then it is 4 and 2. So option B can be the right option. Okay.
Okay.
Yes, it is. It is. Wait. There is one more thing. The distance between distance between the stations will not be changed. So when distance between the stations will not be changed, you have to take care of the area because A and D both have the same behavior. Na? देखो, during in B and D, the acceleration is double. Is it? Top speed is same and deceleration is also same. Deceleration of 2 is equals to deceleration of 1. So what is the trick in this one? You have to find out the area, the distance between these two. So if you see the area of this graph and area of this graph, that would be important. So just a second, just a second. Okay, just see, is there anything I'm missing down? Velocity 2 and 3 is fine. Velocity from 0 to 2 is fine. Then it is at rest for 1, 2, 3, 4, 5, 6, 7 seconds. 1, 2, 3, 4, 5, 6 seconds. And oh, yes. Did you see this one? Is it clear? The time is ending over here. Is it clear to all? So the graph should be ending at this point. So that is why B is not the D is the right option. Yes, I was not able to distinguish where the graph is
इसमें
ending. This is ending.
बी
हाँ
का तो एरिया अंडर द कर्व ज्यादा नहीं हो जाएगा
ज्यादा हो रहा है. जस्ट सी
अगर हम
एरिया अंडर द
कैलकुलेट
कर्व
करें
क्या बन रहा है आपका. Calculate करना पड़ेगा because yes. Okay, so if I just stop it here because I have a next class ahead as well. So if you just calculate area of one, right, base area into height and area of these two, so you will figure out that which graph is the right. The only thing, only key for the right option is area under the graph because distance between the stations will never be changed. Is this clear? So according to that, mean most probably option B can be the right option, but just check the area. If area of D is greater, then discard it. Okay, Ji?
ओके
Okay. So next questions, inshallah, I will explain this all in my next class along with the theory part. So I will appreciate that if you people would uh, work on the momentum part as well because we have completed the general
ओके
physics. So I would, mean, did we go through the deformation as well? Deformation हमारा हो गया या रहता
डिफॉर्मेशन
है?
फिर डिफॉर्मेशन रहता है
Hmm? Okay, that is the only topic from general physics which is left over. So I will complete that topic inshallah in one of the classes. But meanwhile,